Hello, geometry students, and welcome back to another video or lesson. Today we're going to look at calculating the measures of something called the inscribed angles. Can we find the measure of inscribed angles using the measures of intercepted arcs and vice versa? Can I take that arc and go back to an inscribed angle? Now, in order to understand this, we got to go back to something we talked about at the beginning of the year with arcs and angles. Okay, so we had this idea called central angles. If it goes through the center of a circle, right, this angle, CEN, equals the same as the arc CN. Why are they equal? Because it is the central angle, or it goes through the center of the circle, the vertex, right? So that's the most important piece about notifying and understanding this relationship. CEN has its vertex at the center of the circle. Therefore, this central angle is equal to the arc. Inscribed angle has the vertex on the circle, right? It's not in the center anymore. It moved out here on the circle. Okay, big difference. Now, when that happens, this angle measure from I to N to S, that angle measure is equal to half of the intercepting arc, right? So INS is half of the arc from I to S. Or we can say it the other way, right? That the arc is twice that angle measure. But notice, it's because the vertex of the angle is not on the center anymore. It's way back. It's on the circle itself as well. So let's see what this looks like in an example. Find the measure of angle IES and the measure of angle INS. IES and INS. So let's trace it in blue. I to E to S. I'm just going to draw it off a little bit so we can see it. I to E to S. Does that go through the center? Yeah, all right. This is, again, this one's the central angle. And if it's a central, it's equal to its arc. Well, what's the arc from I to S? What's this arc from I to S? It's 120. So the angle has to be 120 because it's a central angle. So they're equal. INS, I to N to S, is not central. It doesn't go through the center, but it goes on the circle. So this one we call is inscribed. Right? It's inside the circle, but its vertex is on the circle. It's inscribed, and it's half of its arc, right? The edges are at S and I, so the arc was 120, so it's half of 120, or it would have a measure of 60 degrees. So again, you gotta notice the difference between central angles that go through the center of the circle versus inscribed, where the point and vertex is on the circle, and the relationship it has with the intercepting arc. That is key number one. Now, key number two is if we have a diameter of a circle, right? A diameter. It goes through the center, and we know it's a diameter, meaning it's a half circle. Well, how many degrees are in this half circle down here? Well, 180, which means this arc out here also has 180. But what's even bigger to notice is, notice I got a point on the circle, a point on the circle, and an inscribed point way over here. This is 90 degrees because I know a semicircle is 180, right? If we know that it's a diameter, we know that intercepting angle over here is 90 and the intercepting arc is 180. And we can use that to our advantage. So here's another diagram, right? Find the measure of ANG, find the measure of NGA, and find the measure of arc GN. A lot of stuff happening here. A lot of stuff happening. So let's start with, what do we see? A to B to G. Well, notice those are all on the same line. They're collinear, and they go through the center, which means this arc all the way out here, the arc AG is 180 degrees. 180. Now, is there an angle that uses A and G? You bet, right? A to N to G, right? They use the endpoints AG, that arc. It's got an inscribed angle, which is half. So this down here would have to be 90. ANG, oh, we found it right there. ANG is 90. Do we know NGA? Right, let's go maybe yellow. Oh, we'll try yellow. Maybe it'll show up. N to G to A. Endpoint, and an endpoint with a point on the circle. So look, here's the arc. The arc is 120. So the angle inside of it has to be half, or 60. So that is 60. Now the last piece is to find the measure of arc GN. They want this arc right here, G to N. Well, how many degrees are in a full circle? 360. We already know half of it's 180, so that leaves 180 for this half. I've already got 120, so that leaves 60 more degrees for the arc GN. So notice how we can use one picture with an inscribed angle and a diameter to find lots and lots of information. Make sure you got these examples and notes down today. Give the practice problems a try to see if you understand it. And if you have any questions, please reach out. Till next time, everyone, stay safe.